Hello guys and welcome back. So let's continue here, and what I want to do is with this offset, which is great, I want to be able to change the amount of rotation as we get further along the curve length. Okay, I want to be able to change the rotation, and what I'm going to do is I'm gonna use a UV texture node to create a the U coordinate that travels from here to here. So let's create that point. Set this to arc length spline, and now we have a UV coordinate. We can plug that into the color to see it better, and you see it's red and ends up black. And if we can use this as a multiplier for the degree, we can change the rotation as it along the curve. So let's use this. Let's multiply it by the x component of the UV, and let's do a fit range. It goes from 0 to 1, so we can specify how much it affects the min and max. So I'm going to expose the min and max here, and let's disconnect the color, and let's set this to 2, template the curve, maybe set it to 1 so we can see it nicely, and let's set the angles to 180. And right now it's affected already, so it's 0 rotation is happening here and 1 is happening at the beginning. I'm gonna invert that. I'm gonna set it to 1 and 0. Okay, and if we increase the 1 value, it's gonna get rotated over and over and over and over as it progresses through the curve. Okay, that's one thing. The other thing that we could do is we have the original position, right? This is the original position of the curve, unchanged. What we can do is we can use another fit range, and let me call this, let me delete them, or let's rename them. So I'm going to call this min position and max position. Okay, and I want to mix the position of the new curve with the old position, the original one, using this new value. See, now it changed. Okay, let's flip the values, or let's do it here. Let's flip the first in and out. Okay, so now as it gets closer towards the end, we can control how much it gets influenced by this offset. And right now it's getting influenced 0 towards the end. Okay, we can also reduce the overall amount along the curve, and we can, like always do, add a ramp. Let's add a ramp and set this as spline to spline, and now I can control what happens to the curve along its length. So I can stop it in the center. I can stop it here and go back to its original shape. I can reduce the overall offset and change it. Okay, so these are all great stuff. So let's reset this, and I'm gonna set this to 60 degree, and this is to 1. Okay, and just have the curve nicely blend towards the end, no offset towards the end. And what I want to do is I'm gonna introduce you to the for each. So I'm gonna create a for each number, and this one we can tell it to run multiple times. So let's select this node. It has this block orange look, which means anything affected by the for each will be inside this block. So for now it has 10 iteration. It starts at 1 and it will stop at 10. We can also limit the max iteration here if we don't want to change that value. So let's connect this guy. Okay, and what I want to do, actually I'm gonna remove that. I'm gonna paste it here. I'll have a copy just in case. And what I want to do is this node here, it's gonna run from starts at 1 and then 2, 3, 4, 5, 6, all the way to 9, all the way to 10. And that iteration loop number is available to us through this feedback node. See here, it says fetch feedback, fetch metadata, and it's giving us back this detail, num iteration value, and I value. And I'm interested in this iteration number. So what I'm going to do is I'm going to create a new value here, a new controller, and call this int or iteration. Okay, let's add this guy. Where is it? So it's here. And the way to access these guys is using an expression called detail, because this is, if we middle click here, it's not a point attribute. We have point, primitive, vertex, and a detail attribute. I'm going to use the detail function, and I'm going to type in // this means relative nodes, and I'm going to use the for each count and the attribute name. See here, it already helps you with the expression. So the first one is the path to the node, the second one is the name of the attribute, which is iteration, and the last one is a float in case you have multiple, it's a vector, you want to import different things. So I'm going to say 0 here, and if we take a look now, it says 9, and right now nothing is changing. We're not using this in any way. So I'm going to right click, copy, and I'm going to paste it here. And we have 10. Let's divide 360 by 10. So it's, 360 by 10, it's 36. So I'm going to take this degree number, which refers to the iteration, and multiply it by 36. And look at that. It's every time it's increasing by 36 degree. And actually we need to add multiply. So let's add a +1. Because I think it starts at 0, and I'm not sure why it's 0 in the beginning. Okay, it looks better now. So let's, so it's this. The iteration is returning 1, 2, 3, 4, 5 up to 9 or 10. It should be 9, and then we're multiplying that result to change the degree value. And look at this, we have every time it changes this value, it generates a new curve and moves to the next one, and these are all the curves generated. To increase this, we can say I want 20 curves, and see now it's generating 20 curves, and instead of a 360 we can say 36, we can say 18. And now we're generating more curves, and we can, not the min and max, we can offset, use this guy as the offset. This is the global offset as well, and this is the min and max multiplier along the curve length. So let's do this. Let's stop this at 3, and let's take a look at the curve rotation. See, now it's getting spirally. Let's turn this on, and now we're getting a much more spirally look. I think too much. Let's say 10. Something like that. And this is the offset. We can also change the minimum rotation if we want to. Let's reduce the number of curves to 10. Set this to 30. Okay, we have some cool curves around this guy now. I'm gonna turn off the rotation. I'm just gonna leave it as it is. Maybe just add a bit of rotation. And now we've done this one time. We've isolated this curve, and we've run this whole process one time. Let me delete all this. And what I want to do is I want to loop over each curve and do this whole thing again with the for each loop. So what I'm going to do is I'm gonna go back to the first section. I'm gonna say for each connected piece, and if I connect this, we should be able to see one curve at a time. And this connectivity is gonna figure out what's isolated, what could be grouped together, and then we can access that in a separate for each. So what we need to do now is we need to plug that here, and this for each is going to be our result. And now I can loop over each curve and run the same process again. Obviously we can access metadata from this guy as well. Okay, we can do this. We can get the metadata of the first loop by selecting this node, say create metadata node, and we can read the detail attribute and maybe add a randomizer, change the generation of these offset, or do anything we want really. So let's increase this to 50. And now we have converted all those nice curves into something much more interesting. And we can obviously add a mountain. Let's see if this works. Yeah, it does. So we can add noise. I prefer to do my own. Position. Let's add this. And let's expose the frequency, offset, and this. Make sure it's a 3D noise. Okay. And what I'd like to do to visualize curves when they overlap like this, I'd like to use a color node and random from attribute, random, and set it to a primitive number. And this is going to generate a random unique color per curve. And let's take a look at the noise. Let's increase the amplitude. Maybe resample them. It's a lot, but that's fine. Set this to 0.2. Okay, and let's just do use an offset. So this is not exposed. Right click, promote parameter. I'm gonna use, let's see, yeah, $F along the Z axis. Let's divide this by 10. Let's hit play, and we can get some cool movements from these curves. And we can do this. We can delete all the geometries, but keep points. And now we have something that we could render. And see, the color now disappeared. That's because if we middle click, it's a primitive attribute. The color is a primitive attribute. We need to change it to a point attribute so that when we delete the curves, it's kept. And to do that, we do something called promotion. We promote the attribute from one class to a new class. And these are the points. You can set them to be displayed as pixels. Set this to dark. And that's a cool particle sim, or a source for an interesting particle sim that we could use with some offset as well. Cool. This is it for this week. Thank you guys for watching, and see you in the next video. Bye bye.